Now let's move on with the module number 3. In this module, we will place our rig into the scene, check all the settings which rig offers, put this rig on the spline, draw the paths to drive, animate multiple cars in the scene, get through the sequencer basics. We will animate drifting and all other parameters, go through the controllers, cinema camera actor overviews, and we will make one sequence with the both cars driving. So first we have these two cars, and let's give it a proper playground, because right now this plane is just not enough. Let's try with some racing track, with the default racing track, so we can better see what is happening with the well-lit environment. So let's add feature or content pack. For this one we will add this vehicle content pack because it has the racing track and some other things inside, so we can just check out how to work with that. This is the part of the Unreal Engine content, so by clicking add to the project it will instantly add it to your project. So here I have it, and in maps we have the vehicle example map. It will give you some error that you need to enable the Chaos Vehicle plugin, but we're not going to use the Chaos Vehicle because our rig is working without any physics or simulation. It fakes physics, so you can either enable that, or I will dismiss it for now because I don't want to restart my project. Anyway, you will not need the Chaos Vehicle add-on. Here we have simple racetrack where we can just play around and try to animate our cars after we get familiar with all the settings. First of all, let's put our blueprint into the scene. So this is our car. As you can see, it works with the suspension, it reacts to the bumps, and basically is animated properly. Let's go through all the settings which we have in this rig. First of all, I would like to start with read-only parameters which you are not able to edit. They are only for reading the parameters of the rig and checking this information, just like speed or steering. So you can check the speed. It is calculated in kilometers per hour, and it is needed, for example, if you're doing some really fast curve and you need to check if it is real that the car can pass the curve at this speed, or if the client says, hey, can this car drive exactly 90 kilometers per hour? And you can actually adjust your car movement so you'll get this speed. So if I move that, you'll see that it's just like it's changing when I'm moving it, and this value is just calculating the transform of the car in the scene and giving you the information about this speed. And the steering shows you how much the wheels are steered during the animation. Car scale, just for scaling your car, if you would like to make the car bigger or smaller, that only depends on your choice if you would like to do that. The next thing is body height. We already talked about that when we rigged the car. Basically, you can make it lower, so we will have some really nice fitment, or really low car. Or if the pivot of your body mesh is offset, not in the proper position, which you would like to have, and you need to adjust it so it sits properly on the wheels. Let's keep it minus 34 as default. So front wheels offset, we also got through that. It basically gives you the offset of the wheels. You can change these values for every instance of your car in the scene, so it can be different for each car. And if you reset it, it will go back to the value which you set in the blueprint here. The same goes for the rear wheels. So we can make it wider. So if you have really wide car, you can adjust that one. Steering wheel rotation multiplier. So as you have the steering and the steering wheel, like we set up in our previous part, you can define how much will be the rotation of the wheel by the rotation of your steering. based on your steering. So by default, it is 4. So if we go with the steering parameter, let's first disable this. So if we go to steering parameter and set our steering like to 60, we will have 2. Let's enable controllers. That will be a little bit smoother. So if we steer it maximum, it will have 4 turns to the maximum value. You can increase this value or decrease this amount in the steering rotation multiplier. So for example, some of the sports cars, they are having just a little bit of steering wheel steering. So if you decrease this value, for example, to lower value like 2, it will not do so much of the rotation when you make the steering of the wheels. So let's reset that. So the default value is 4 and I will keep it like this. Next is tracing ground. We'll talk about controllers a little bit later because it has some special functionality to that. So the trace ground, as you see, the car is always attached to the ground and it's sticking to it. You can't, move it. So if you would like to disable that, or if you would like your car to fly or jump over something, you can disable this feature. Or if you have some sort of bad model in the scene and you can't figure out why the collision of this model affecting the car, you can always disable trace ground and it will be adjusted only to your position which you define by the transform. So let's keep it on. The next is the front and rear wheel trace correction. It is done for the purpose that it will have the proper point of contact with the road, because how it works that the rig defines the radius of the wheel and creates the sphere which is touching the ground, but if you set it to 1, it doesn't have the proper connection and it even can be over the ground, so it doesn't touch the ground properly. So that's why the default value is corrected a little bit, so the car has the proper point of contact with the road. You can use this also for doing, for example, Dominic Toretto wheelies, like when you have the really powerful car, it can jump on, it will increase the size of the sphere which is traced. So if I enable the debug, you can see that the wheel sphere trace is changing its size and it will be increased and you can do the wheelie. Also, you can go on the negative values or like smaller. In that case, you can use that if your car drives in mud or dirt or in some puddles or water. You can change this one so the car will be just in the dirt. For wheel trace, there are 2 options of how to do the wheel tracing. The default one is sphere, and sphere provides smooth collision with the road bumps or curbs which you can have in the scene. So if I take this square here and put this over the wheel, you will see that it goes smooth through this sphere and it's like touching really nice and it goes really smoothly. But there are some cases because there is no cylinder trace inside of Unreal Engine, and if your car comes close by to some object, it will react, the suspension will react to it, even the wheel is not touching it at this point. So that is not what you're looking for, and for this reason there is line trace. The difference between line trace is that you can pass by really close to some objects and the wheel will not react to it. will only react to it when it touches the line in the center of the wheel. But here is the difference. So the rig will not react unless the object reaches the center. And this can be the problem in case if you have some bumps and you would like the wheel to go really smooth over it. So use these features based on your scenario. If your car drives on some really narrow road and you don't want to, collide it with some objects which are passing close to the wheel, you can do it like that and set the line trace. But if you want some smooth going through some sort of curb, or when the car drives out of the parking lot, you can use the sphere trace. And in that case, the wheel will react smoothly and your car will be passing over the curb smoothly and really nice. So if I take it right now, for example, we are parking, doing the back parking like that, and the wheel will go just like this. With the trace debug, don't use persistent, because those lines will not disappear unless it is the project is reset, because you would need to close the project and run it again. So use either for one frame or for duration. I will set it back to none right now. Editor update disables the update of the car inside the editor, because it constantly runs on the tick and doing all those functions. And if you need to make it in path tracing and do the preview, you will not be able to accumulate the frames, because the car is constantly, looking for the ground. It's just like touching it and doing all of the checks. And if you need to preview in path tracing, disable editor update. And as you can see now, path tracer is able to accumulate the frames. Also, if you have multiple cars in the scene, when you finished animating one of the car, you can disable editor update to save some FPS in your scene. The next thing is the tick FPS. It does not affect renders. It will be out of the queue when you are rendering, but it is needed for the previews of animation and in the editor to make all the function work. If you have some choppiness or your editor runs at higher FPS than the tick rate, then you would need to increase this amount, for example, to 120. Because if your car is moving too fast and you have more FPS in the scene than the car tick rate, it will be choppy. But when you increase the tick FPS, that will be much smoother. But again, as I mentioned, it does not affect the render, because during the render it goes into simulation mode and then it goes in the tick of the, and it goes on the game tick. So it will be working just as intended by using the simulation, and it will not be affected by the tick rate. So it will be out of the queue. Visibility just controls the rig visibility, it just hides it or shows it. So you can, for example, put two rigs of the different color and switch between them, for example, in your animation. You can come up with more scenarios by using the visibility. Then other functions we have created together in the previous module, which is brake, which enables the emissive material for the braking lights. Daylights enable this DRL, so this here in the front and on the back. Turn left signal is basically our blinker, and turn right is the same thing. they are always using the same time function. So that means they will be synchronized. If you would like to, park a car and do that, so that will be synchronized, and doesn't matter if you turn them in the different time moment, that will be working simultaneously all the same time. It will be synced. The brake temperature, also the function that we created, which allows us to make the emissive material for our brake and make it glow when the car is braking. Next thing is the suspension and suspension stiffness. Suspension stiffness defines how fast will be the reaction of the body to the wheel collision. So if wheel collides with something and goes like that, there is some latency between that, right? So the wheel even can go through the car. So there is some latency. And if you change this value, for example, to 9.9, it will be very fast, almost instant. So there is less of that. And if you set it to 10, you will have the rigid body. So there will be no, at all, no difference or no latency between body and the wheel, which looks really, really strange. But that has the purpose. So, for example, if you have the lifting platform and you show the car, emerging from somewhere, you would need this rigid body. You would need to set the stiffness to 10. Otherwise, you will not be able to, let's look how it will look if we change this difference. See what is happening. And that will be happening all the time if you're having some lift platform which gets the car, for example, from some garage or something. So for that case, you definitely need the rigid body suspension, so you'll not have this issue with this elevator platform. So let's set it back to 4 and delete this one. Auto pitch determines the pitching when you move the car. So if you move it back or front, or if you animate the car and it stops at some point, like brakes really fast, your body will wobble a little bit. That is all faked. It's simulation. And you can disable this by setting this parameter to 0 if you'd like to animate the pitching automatically, or if you don't want the car when you start rendering, so it will not lean back, like it's accelerating. Make a feeling it's already moving, it's already on the move, it's not accelerating anymore. But this is useful for making like the start animation or burnouts. Let's keep it to 5 for now. Body leaning is basically how much the body will lean during the steering. So by default it is 4. And if you have steering, you can notice that our wheels are turned. And if you change the steering right now, or let's make it with the controller again. So if you change the steering, you'll see that the car will be moving on the side because the rig tries to imitate the physics as much as possible. And when the car turns, all of the mass is just moved to other side. Obviously, for sports cars with a tougher suspension, it should be less. So when you increase the suspension stiffness, this will be affecting the leaning less. But you can disable the leaning if you would like to make static renders, because you would like to have the car with turned wheels and standing in the place like that. Then you don't want any leaning. You want the car just to stand here with a cool posture with the wheels turned. And for that one, you can disable body leaning, so it will not affect the body when you turn the wheels. Let's disable the steering, back to 0, and get back to our parameters. As I said in the very beginning, you don't need any camber in your model. You should eliminate camber from your model when you import it to Unreal Engine, because otherwise you will have improper pivots and the wheel will be wobbling and shaking. You have the camber inside this rig, so you can set the front camber to 2 and rear camber also for 2, for example, and you see it's already like looking much cooler. You can go higher with the values. You can even go with values which are completely like negative. But what I like to do, for example, if you are doing it with the sports cars, you can really go overboard and, for example, also adjust the body height and change it to -40. And let's look at that fitment. It's just like perfect fitment. So if you're doing some JDM cars or some really sports cars or stance culture things, you can do that in the rig. You don't need to rig the car in Blender, add bones and something. You just can set this really cool like that. Also, you can set these parameters and animate them in Sequencer for making the view of the pneumatic suspension, that the car can lower itself or go up. Let's set up this bag, and I think that's 2 and 2 just enough. Sometimes these values are even less for the real cars, something like 0.8 or 1 degree for the camber. So even let's put it a little bit lower. I think that will look better. Yeah, 36 is really good. So that sits really nice. The body pitch and body roll, pretty much self-explanatory. So body pitch allows you to animate the braking, so you can use that within the sequencer when the car brakes, moves there. And the body roll gives really nice feeling. For example, if the car goes on the bumps, or if you're using the drift, you can compensate that for if you add some drift here, drift angle, you can compensate with the body roll, so your arc will not go through the wheel, or the wheel will not go through the arc. So you can use the body lean or body roll for that case, so like compensating like that, right? So you can go even negative. The thing is, it's just like to prevent the wheels going through the body. So we can disable it right now and disable the drift. Okay, so vibrations give some more realistic feeling when the car drives. There is overall vibration multiplier, which is set by default to 0, so you will not render the car shaking by mistake. So it gives some amount of the shakes on the wheels and on the body. So if you are driving, for example, over some rocks, it is really good to add some roll vibration amount and increase the roll vibration speed by 1.5, for example, and you have it just like wobbling, driving over some rocks or some like bad ground. And anyway, this is really good to add for driving on the racing track, because there is no thing as like completely flat road and asphalt. The car will be wobbling a little bit, especially on the high speeds. So you can use these values for this reason. And if you set up, for example, the wheel vibration amount, let's set the speed. So I usually use like something like 9.7, because there are small bumps always, and at high speed your wheel should be shaken a little bit. So I add that to make it feel more real with some vibration speeds. Also, all of those functions are using Perlin noise. So it means that every time you hit render button, it will be generated differently. For that reason, we have the user-defined time. If we create the level sequence, ls vibration, and add our car to a sequencer, we need to add user-defined time. Put the tick here, click there, set the vibration to 1. And now we need to calculate how many seconds that's going to be. So 30 FPS, 149 frames, from 0 to 149. It's 115 total. That means 5 seconds. So make this linear because time should go linearly. It's not cubic or something. And set it to 5. And in that case, you will have persistent result each time. Why it is needed? For example, you've been rendering something and then, hey, there was a bug. Some strange object appeared for a brief of a second and you don't want this object in the frame. You delete it and now you need to render everything from the beginning. No, it's just like not good. So you can render the chunk of it, like for example, from frame number 60 to frame number 75. And in that case, you will have the proper render with the same result on the body shakes. You can define those values like 2. You can set the wheel vibration amount to vibration speed to 9 or something like that. And you see, it changes everything, but you can re-render. It's always persistent result, and you will have it the same in the renders if you would need to re-render the portion of your animation. So now let's reset all of that.